Hello, and welcome to this episode of Data Unchained. Great guest today that has a lot of experience in a lot of different technologies around putting data to work around the globe and kind of how the industry has evolved over the years. I'm super excited to invite David Chappa, who is a longtime industry colleague. He's worked at competitors, he's worked as an analyst, he's worked as a friend, he's a neighbor. It's great to have you here, David.
Thanks a lot for having me. This is going to be fun. I'm enjoying this already.
Tell us a little bit about your background. We can see, for those of that are watching on video, that you have kind of an eclectic, even background behind you right now. But tell us a little bit about, you're one of those unique people that's not just a technologist, but has a lot of other interests in life.
Yeah, so technology has always been the thing that I've been rooted in. But music is the other thing that I'm very, very passionate about. So I'd say there's two passions I have: technology and music. And you see a small collection of guitars behind me. And actually over behind that brown guitar is Johnny Cash's road case for his Martin D35 that he used to travel with until he decided to do more air travel. And he got a different case for that so it could fly in the belly of the plane.
That's pretty special.
Yeah, that's a pretty cool thing. I don't think I'll ever part with that. You can't see it, but it does say House of Cash on the front and address and telephone number. I've been playing guitar for almost 40 years, semi-professionally for about 25 or 30. And then I did a stint professionally for about 6 years where I was doing a Johnny Cash tribute show. And I play with Johnny Cash's drummer, W.S. Holland. And we have performed that show for thousands of people, and it's been a blast.
You didn't do a tribute show at the Warrior Dash in Copper once, did you?
I did not, no.
So this isn't embarrassing. I shouldn't even admit this to you, much less everybody who listens to the podcast. But we were up in Copper doing one of those, mud runs where you do obstacles and run around the ski resort in the summer. And the night before, they had a Johnny Cash tribute band, and I didn't actually realize it was not possible for Johnny to be playing. I thought it was actually him. And, maybe there was a few cocktails involved. And I was like, oh my God. And I put on Facebook, I'm listening to Johnny Cash, which I was quickly ashamed and didn't know that's not actually Johnny Cash, Molly.
Yeah.
How funny would it have been if that had been you?
That would have been funny. That would have been funny. But that's my passion, music and technology. And as a matter of fact, I'm actually playing a gig this Sunday at a place locally from 1 to 5. But yeah, I
in Castle Rock, Colorado.
In Castle Rock, Colorado. It's fun, and it's what's brilliant about, I think, both music and technology. There really is a connection there because you can't see it to my right, but I've got my recording mixer over here, which is 100% technology, right? And you think about how data flows, signal flows. This signal is the data that goes into my board. That translates into something meaningful and compelling that I can create and then deliver. And the collaboration that I do with a friend of mine in Tennessee, who has the same board, is incredible. So I can record music here. I can send him all the stem files. He can bring it in, and then he brings in studio musicians to add their layered parts onto the song that we're recording, the song that I wrote. So, it's interesting for me as I look at what I do professionally on the technology side and the music side, and there's a lot of intersection.
I think that's kind of a cool concept. So you can create music with somebody who's not local to you, blend it, mix it, update it, whatever you want to do, sitting from your home offices, not unlike us podcasting from our home offices or, collaborating on data science.
I remember 20 years ago working for another company. Sony was a big customer, and it was a big deal for them to replicate the tracks that they were using from LA to New York for background vocals or for, other things they were doing from an engineering perspective. That was a big deal. And now you look at what, David Chappa can do from his home studio with a guy who's got a professional recording studio in Tennessee. I can do that very same thing. I mean, the advancement that we have seen in technology, just from a hobbyist perspective, is really incredible. Now take that to, the next level and what we look at from the industry, and it really has opened things up considerably.
It's a really interesting segue into the conversation about data and how businesses are using data. You and I were talking, as we were getting ready for this conversation about data locality and the kinds of conflicts that occur as data starts to become more localized. Maybe just let's start off the conversation there.
Well, just take this situation here. Having all the files right here, I could very easily put it up into a shared drive, right? Which many of us do. Dropbox or whatever, right? G Drive. And getting access to that, if you think about getting access to that from an application, there's a certain bit of latency that an application can tolerate. There's a certain bit that it can't tolerate. And so getting that data actually to a place where there is not going to be a challenge for the application is really important. Years ago, when we were talking about erasure coding, remember that when it first started?
Absolutely.
It came out.
When this new thing instead of RAID came out and it was done in software.
And we were talking about how erasure coding would make life so much easier for people with big amounts of data because you can distribute that. You don't have to send all of it. You can distribute it. That's kind of where we're at. You've got to be able to get access to the data more locally. And so we've gone beyond that. We're still using erasure coding, of course, but we've gone beyond that. Getting the data as close to the application as possible allows you to be as productive as possible. Same thing with this. If I can get this data to, my friend Dan, as quickly as possible so that he can get access to it and get access to the musicians, their schedules, their timetables, and then get the work done, then we don't lose any money. I don't lose any money because I'm the one paying for the musicians. If it takes them longer because of the latency issues, all of a sudden that opens up Pandora's box and budgets get squashed, and in some cases, projects get either delayed or terminated.
I also think that, the analogy of getting a file out in, let's say, Google Drive, the benefit you get of being able to share it, do change control, access from outside your organization. I think most of us, no matter what we do for a living, can understand what the big benefit that was versus emailing around a Word doc that now you had change control, you weren't able to collaborate on. Like, I think everyone really... I can't even fathom going back to doing my job where you had to email a Word doc, wait for the person to give you input, email it back, and then send it to the next person. That I can't imagine my personal productivity not having those tools. And when you think about massive data sets, hundreds of thousands of files, many petabytes of data, whatever it is, that same concept is fantastic if you could accomplish it with these massive data sets. But tools like SharePoint and Google Drive don't work for these massive data sets for a variety of reasons. So you think about, okay, why not? It's the scale, it's the latency, it's the performance, it's the, ability to derive metadata and information from those files that is pretty specialized beyond what people do with their home office tools, right?
That's very true. I don't know how many years ago this was, but I know I was working for ADIC. So it was probably
That's
around
2000. Name I haven't heard in a while.
Right?
Yeah, but amazing company in its time.
Yeah. Well, in 2003, when I started with them, I was looking at data. I was a big backup. I still am a big backup guy, backup recovery, disaster recovery. But I was looking at data and looking at the technology they were developing at the time, which was their Pathlight VX, right? It was their virtual tape library. And one of the things that I said in an engineering meeting, I said, at some point, the metadata is going to be more valuable than the data itself. And I got a lot of pushback from everybody. But the reality is the data around the data really is the most important thing. Now, we have constructs today to protect data. Data protection, backup recovery, some would say those are table stakes today, right? Everyone, you can do that. But getting access and understanding and discovering the data around the data, not everyone does that as well as potentially others. And so I think having that access and having that understanding is super important. That's about locality. It's about creation. It's about access time. It's about so many things that's critical to that data itself.
That brings up all these memories of things we've discussed in this industry over the years. And it makes me think a little bit about that same analogy of data versus metadata. Why does it matter? And we spent so much time figuring out how to just store data, make bigger disk drives, make higher capacity tape, make sure it's reliable, make sure you can recover. And that's all about storing the data. And back when I was working more in the backup industry, there was a lot of conversation about, but that's really just insurance policies. That's your homeowner's insurance just in case. We put so much effort into that, just the storing of data versus the using of data. And I think that's really what you're getting to around this concept of metadata is, okay, we've as an industry focused for so long on just how to find a place to put all this data that's being created so fast. And now there's a huge focus on, wow, we're a data-driven world. How can we actually get value from the data, insights, solve COVID, whatever it is. And that's really all about metadata and harvesting information of those big data stores. Is that generally what you were thinking back even when you were at ADIC?
Oh, gosh, even before that. So I know the year, 1998. I was working for a large telecommunications company in northwest suburbs of Chicago. And it was all about the data itself. They wanted to get access to the data and run some tests, validation tests, whatever. They were running ClearCase for development, so checking in code, checking out code. They wanted to run some tests against it for other things. And as the backup guy, I said, "Hey, go right ahead, but if you mess up production, this is how long it's going to take us to recover." And so at that point, I thought, man, we are, and I started using this phrase, we are dead-ending data to tape. Now, I'm not a someone that's going to be a Debbie Downer on tape. I think tape still is a good solution. I think that it has its place. Tape certainly has shifted down the continuum of data protection quite a bit, but that's where we were before. We were dead-ending data to tape, and it was in a tarball, right? So it was in a format that no one could read except the application. What was the purpose of that other than just protecting us against failure, file deletion, right? And there was nothing else there. So if they wanted to test, I had to restore all that anyway. So that got me thinking, there's got to be a better way. So it was around 2000 that I started to look at just disk. Give me some JBODs and let me back up to disk. And so while it was still in a tarball format, it was faster to recover that because it's coming off of disk. I don't have to worry about shoe shining or anything like that with the tape. And then it was around 2002, 2003. That we started to see deduplication come in. So we had this infinitely deep, well, not infinitely, still was, had its limits, but we had a deeper,
10 or 20 or 40x deeper.
Yeah, whatever that ended up being
for your compression. Mm-hmm.
But then we had the challenge of recovery again with that. So we've been in a state where it's been very difficult. Fast forward. And it really is now, we've got the ability to recover data into a sandbox or a playground area where you can run these types of tests and you can run these types of validations and audits very, very quickly. And so, yeah, that's kind of where my head was going with this is, you've got data. Let's not dead end it. Let's figure out a way you can use it. It's an investment. It's a coin. Think of it as a coin. How are you going to invest that coin?
Exactly. During that same kind of time frame, I was tracking on a similar path, and this was when we created the Active Archive Alliance. And it was around the idea of, okay, you've got these massive data sets, largely at the time on tape libraries, in a tarball, VTAR, whatever it is, some kind of proprietary format. And the idea of putting a file system in front of that, so you could use NFS, SMB, standard interfaces, was unlocking all kinds of opportunity for now application owners to be able to interact directly with the data. Maybe it was a bit slower, than if it was on flash or disk, but you could actually interact with it, access it directly, and not have to go through an IT process of recovering it out of a tarball to a file system to then be able, or to a database, whatever it is, to be able to work with it. And that was a big advancement, being able to do that. And some of those technologies had been around a lot longer, but most general organizations, HPC maybe knew about it, but the rest of the industry did not. And that's really kind of one of the evolutions, was starting to make data accessible to the application or to the user directly. But you think about all these tools, and that kind of moves on to this concept of data gravity. And we've still created these, because of the infrastructure-centric approach on just struggling to be able to retain data as fast as it's being created. We've created these pools of data that have an enormous amount of data gravity. And, within the industry, and I mean, you've been a bit of a pundit in addition to a technologist, and, you could ask these questions a lot, but, what are your thoughts on data gravity? Is this something that vendors created selfishly, vendors created because there was no other answer? Is it just a law of physics we can't overcome?
So some people may not like what I'm about to say about data gravity, but I think it was a term that was developed so that we had something else to say about data. I think data, when I think of data, data carries weight when you need it, right? So when you're not accessing that data, it can be somewhere else, and you can talk about data gravity and how you have all this data you're managing, but really, data itself is only that important to you when you actually have to have access to it. So, I think about data being spread across multiple silos of storage, right? And so sometimes you do that in a hierarchical process where you're moving it to different tiers of storage. Other times that's done because IT has brought in a new tier of storage that they want to use and play with. Maybe it's faster, it's bigger, it's deeper, whatever that is. But I have a hard time with the with data gravity. I remember the person that first came out with that. I kind of liked it at first, and then I started to see that there was a lot of misuse of that term from the original intent. Bottom line is that for me, the data carries weight. I think of that Dave Clark 5 song. He ain't heavy, he's my brother. It ain't heavy, it's my data, and my data needs to be there when you need to have access to it. So I've got to have a system that's going to allow you to find it, get it, use it, and then produce with it. Whatever that looks like. You want to call that data gravity? Let's call it data gravity. You want to call it accessibility? Let's call it data accessibility, whatever that is. But that's what it comes down to. And I brought up the word silo. I don't think anyone in IT has ever woke up in the morning and said, you know what? I really want to have 4 or 5 different silos of storage. I think that would be a really fun thing to do in my environment. And that's why the metadata is so important, because when you do have these silos, you do need to understand locality. Where is my data? What is the level of importance, or that weight, if you want to give it that? And then what are my best methods and approaches for allowing my customers, my end users, to have access to this data?
So I think that the concept of metadata and data becomes even more important if you kind of follow this line of thinking, that generally metadata is what, a fraction of a percent of the size of the actual data set, depending on what kind of data it is. But it's small, it's light in comparison. And if you can think about moving metadata around, that's realistic, especially with 5G networks and the tools that are out there to WAN acceleration, things like that as you're moving around. That I think that's another piece that people often don't think about. They think about, there's no way I can move a petabyte, but there is a way you can move a fraction of a percent of a petabyte, especially if it doesn't have to be done real time, and that as an industry, I think, as people think about I need my data silo, because it has certain attributes. It has a certain cost profile, performance profile. Great. IT can do that or whatever fits within budget. But if we can raise this metadata up and make it accessible and share it in other places, you kind of overcome this concept that you have to be local to your data because you can move your metadata around. Does that track with how you would think about it and how the industry is evolving?
Exactly. And I've written about this. I published a book in 2003, I think it was, same year I started with ADIC, called Implementing Backup to Recovery. And it was about understanding the data, the nature of the data, right? When you talk about disaster recovery, business continuity, one of the things I've been preaching for 30 some years is you got to really understand the data that you're protecting so that you can restore the data that you need when you hit that wall. And that wall is a declaration of disaster. So when that happens, you need to understand what you're recovering. If you're recovering meaningless data, meaningless being maybe it's MP3s that are non-essential to run your business operation, that's taking up very valuable time. So if you can at least start with the metadata and understand the nature of the data and then create some baselines, then all of a sudden you can have a better understanding and insights into what you're managing, protecting, and potentially having to recover. So I think that's where, for me, that's where I see metadata being super valuable, is just in the categorizing your data, putting them into certain buckets. Back in the day, I used to tell people all the time, when you get a new file system and a new storage repository, create functional directories and then put the data for those functional areas into those directories so that when you do a recovery and you set up your backup policies, you know exactly what is the priority. And of course, nobody ever did that. So
it's very hard to control user behavior at scale, isn't it? When you think about the importance of this, and while we talk about it a lot in the data industry, I don't know if everyone really puts the pieces together because they don't sit and think about it on their drive to work or on their bike rides like we do. But this data relevance, and you think about, I don't know the latest data, but there's more data created every 2 years now than was created in the entire history of the world, or whatever the latest numbers are. If you think about the evolution of things like artificial intelligence and machine learning and these applications, which can derive all kinds of interesting insights that we in our human minds might not even think to ask, or certainly couldn't process that much data, it becomes very relevant to think about, okay, I spent my last 20 years of my career, or my IT team spent the last 30 years storing all this data. Imagine if you could make that data accessible to, and no matter if it's in a tape library or in a VTL or in a cloud S3 bucket, whatever, to AI and ML to start to learn from or gather information, that all of that data now can be used, and it's not stuck in a, oh gosh, I don't know where Max put it in his folder 20 years ago, so I don't know what to do with it. We can actually use all of that data. And to me, that's where this conversation becomes so relevant, that not only is it a forward-looking conversation, but you could actually get a lot more information from all that work you did over the last 20 years.
I know that data point you're talking about, by the way, because I think it was around 2006 that IBM Research came out with this white paper on the amount of data that we are creating as a society. This was 2006. They said we are creating 2.1 quintillion bytes of data every day as a society. That's 2.1 exabytes of data. That's 2006. If you look at IDC, look at some of the other major players in the research, they're projecting by 2025, I think it is, that the universe, the data universe, should be around 184, 185 zettabytes of data. Now, does all that data need to be managed, protected, and curated from the enterprise? No. But the fact that that data is growing at that rate, and I tell people all the time, when I give presentations, there's always a slide in there from marketing that talks about data growth. And I ask for a show of hands, how many of you know that data is growing? Okay, great. Everyone knows that. Now let's talk about what the depth of that growth is and how is that affecting your day to day. That's really what that slide is about. It's not about the fact that it's growing. It's how is it affecting you, IT managers, IT admins, IT directors. And the fact is, it's a challenge for them because to your point, how do I find, how do I find Max's golden chest of treasures that he created when he was here, and now he's no longer here for us to contact to find out? That's the problem I think we're seeing with a lot of management over the data in these silos.
So one of the areas that I've had really interesting executive staff conversations on in the last 5 or so years has been as data scientists have come into the organization. And you have these folks who are coming out of school largely that are code horses. They are, analytical. They're ready to do data science. And then they show up and as a team and say, okay, I need my data IT team. And, in some cases, there's a data engineer creating the data purpose built for what they're doing. But in a lot of cases, they need to harvest those old systems. And so IT gets put in an even tougher spot that now not only are they trying to serve their budgets and their data growth, but they're also trying to feed this new team of data scientists who can't self-serve really because of the way the data has been stored. And so it's really create even more pressure. I always think that all the pressure ends up coming still on IT in these environments because they have to be involved because of the way the architectures were set up over the last 20 years. And by no fault of their own, it's what was available.
100%. You bring up data scientists. I feel like I need to put on my beard so I look more data scientist-like. When that whole title started to become more relevant in IT and your chief data officer, one of the things that I asked a lot of questions about, that role and what the intent is of that role. And I got the best definition from a guy in Singapore. He said, most important part of my role is to know what questions to ask of the data. I'm like, that's great. I said, so you get access to that data immediately, and then you can kind of create your data schemas. He's like, well, getting access to the data is different than knowing what questions to ask of the data. And so to your point, how do I extract that value? How do I get that? And it's not just the data that's spinning on disk. It's data that's under management. And I think that we sometimes forget that data under management might be in a tarball still. It might be on an LTO cartridge. It might be anywhere else other than a spinning
scientist machine next to a sequencer, right?
Right. Yeah. So you've got to be able to have access to that data. As you were talking, I was thinking one of my clients, it was a financial company up in Menomonee Falls, Wisconsin, which was a great thing to say, Menomonee Falls. I was consulting with them. I was on a 3-month contract, and I stayed there for like 2 years, consulting with them on data protection and disaster recovery. One of the things that they did was they made duplications of their tape and sent it off site forever, irrespective of expiration. I told them that was a major exposure. You needed to bring that data back, or those tapes back. You need to, get rid of it. And because that if you get subpoenaed, they could have access potentially to anything else that's not expired. The response was, we have enough money, and if we get sued, then we can deal with it. Well, they came under investigation, and long story short, some trading abnormalities were found, abnormalities, and basically the company's acquired by Wells Fargo, and the executives, barred from trading for life, that type of thing. Again, having access to the metadata, knowing what data you have under management is super important. It can be the difference of knowing what to ask of your data from a data scientist perspective, or what we legally need to maintain and retain, and what we can legally get rid of. And so this is an understanding of data that goes beyond just, I want to know how many MP3 files we have on on our system. This goes into much greater depths. What are we protecting? Okay, we're protecting our email. Great. Now, how long do we have to keep that for? 31 days. Great. How much of that are we keeping that's beyond 31 days? We need to eradicate that data. So the metadata goes beyond just even what you think is the normal use of metadata in, categorizing, understanding, locality, creation, but also the after management of it.
At Hammerspace, the company who I work for, we're using a term which isn't new in the industry, but it hasn't been used that much around data objectives. And so instead of setting a policy and trying to remember for my various compliance rules, delete this after this amount of time or archive this after that amount of time, being able to set objectives as a business or as an IT administrator saying, my objective is I want to protect against this, meet this compliance rule, and then have the system just automatically take care of it across silos and softwares and things like that. But those objectives have been difficult to translate into a myriad of policies and different software and storage systems just because there's so much to do. And that's another challenge IT always ends out in. But that's really what it's about. You have to meet your business objectives. And sometimes that's innovation, sometimes that's protection, sometimes it's avoiding ransomware. And the more we can do as vendors to help make that easier and maybe more automated, the more successful organizations will be in meeting their goals. Thinking about vendors just for a minute before we tie up, we've talked a lot about vendor technologies, some things, proprietary things like, proprietary tarballs, things like that. Where do you think our industry should go in the next 10 years to help companies accomplish their objectives? And I'm thinking about open source, I'm thinking about ease of accessibility, any of those things. What would just jump to the top of your mind as far as what vendors can do to make this easier on organizations?
Boy, that's a loaded question. There's a lot of things I think that we could do, and I think that it's a challenge for some organizations to say, you know what, I'm going to turn the key on this and make it open source. But there are certain areas where I think that's important. That's a critical thing to do for the greater good of IT and for, in some cases, national security. You talk about ransomware. I think, from the ransomware side, which is something I've been looking at quite a bit, there's got to be something more that's happening. I don't have the accurate stats here, but I'm pretty confident that the point in time when customers identify that they have been infected with malware, right? Malware, ransomware, what have you, it's not when they get the ransom. It's usually about 80 days in the past when they first were affected. And years ago, like in 2015, that number was 212 days, 222 days. So, understanding the data movement, understanding, anomalies. I think that's the thing that we need to look at really in managing data are those anomalies. Creating a baseline, and then from that baseline, if I see anything that goes off, up and down, it's like a heartbeat. Okay, if your resting heart rate is X, and I see that it goes up by 7 points, 10 points, there's something alarming there. I wear a fitness band that tracks my heart rate, and if it goes up above a certain heart rate, it's going to say either you're working really hard or you need to call 911, right? So those types of things I think that we need to look at from a dashboard perspective. They're not. It's not binary. It doesn't say okay, we are infected. We couldn't in fact have a migration going on, so we have multiple terabytes of data being moved.
Sure, but alert the human to take a look.
That's my point, right?
Right.
I've found an anomaly. I am your security bot or whatever that is, and you send that off to the SIM, and now your network security operations guys and gals are looking at that, trying to identify okay, what's really happening here. I think that's one of the areas that we should be looking at bolstering quite a bit.
That makes a lot of sense. I mean, you think about everything we're talking about, it's really not manageable by a human being, no matter how intelligent the human being or team of human beings is. That automation where software can, they're never going to replace the humans, or at least not in the foreseeable future. But having software help them where to take a look, where, automate things instead of having to manually build policies or write code to script things, a lot of things to make the humans more efficient. I would tend to agree that that would help the industry at large, and something vendors really could help to do.
Right, exactly. And that's what I think. I think on another side where it's not necessarily open source, but we've been talking about this since 2015. The Department of Energy has been issuing grants to different organizations to build the first exaflop supercomputer. And we're not there yet. And I think one of the reasons we're not there yet is because we haven't found a file system yet that can actually feed the cores of an exaflop supercomputer. But I think once we reach that level, I think that from a research perspective, that's going to change the game for us. Not only nationally here in the United States, but globally for everybody. I mean, it's going to be a good thing for us to reach that level. And it was supposed to be delivered in 2020. We all know what happened in 2020. And I think that 2025 is the new date that we're looking at. But I'll be excited when we actually see a true exaflop supercomputer. That means that we've also developed a file system that can drive those cores, which is going to be very important. But
absolutely. I think that I could talk to you about all kinds of different topics on this, and it's interesting that that idea of scale. So exaflop requires massive performance, read, write, I/O patterns, but also massive scale. And this is an interesting thing that object storage doesn't overcome. So object storage is massive in number of objects, but it doesn't serve that purpose of an exaflop file system either. So it's interesting that as you watch how innovation has occurred, it's been kind of like, okay, let's pull the operating system out of the server and put it in the storage array. Okay, now let's scale across arrays. And then it was like, okay, great, build object storage. Now we're back to, but we still need that file system and we need it at scale. And I know there's a lot of very interesting conversations occurring there in the innovation side. But it's a great way to tie it to some of these national security, as well as it helps drive our economy. The companies or the countries with the biggest supercomputers or the most compute power tend to be the economic leads too. It's interesting that you can almost track it directly when you look at the top 10 largest supercomputers. Those are usually the largest economies too. So it all matters in interesting, interconnected ways.
I think the fastest supercomputer still to date is in Japan, and I think it's at 415 petaflops, I think.
I haven't looked at the list in the last couple of years, but it certainly could be.
I looked at it within the last 6 months. I'm pretty sure it's still in Japan. Now there's some strides being made on the where like NVIDIA with their GPU technology, and they're working with AMD. I believe it's AMD. They've been able to kind of get bursts at exaflop, but it's not a consistent. So I'm hopeful as I see this stuff happen. And here's the cool thing about this. I know this is completely off our topic here, but here's the cool thing about this is when I start looking at the supercomputer end of things, it reminds me a lot of the Unix community, where everyone is willing to share anything and everything you have to try to reach the end goal. And so it's kind of like open source on steroids, the supercomputer world.
Yeah, it totally is.
Reading this stuff has been just fascinating for me, and seeing what people are doing and learning about what file systems in open source potentially could reach those levels, and then what file systems I'm looking at in the market today that I think also could hit those levels probably more quickly.
Yep, absolutely. Well, David, this has been great having you on. I tried to throw you a curveball at the beginning and get you to play some music for us, and I didn't give you enough notice. But where can we, thinking of this collaborative, distributed world we live in, where can we hear some of your music? I certainly know where we can find a lot of your technology insights.
So Spotify, they put up an EP of some original songs off an album that I recorded called The Storyteller. And so that's on Spotify. That album, actually, the EP, has W.S. Holland playing drums. Now, W.S. Holland was Johnny Cash's drummer for almost 40 years. And he and I played together for 5 years until he passed away in 2020. But the last 2 albums he ever recorded were mine. So I feel like that's a pretty good thing to have on my musical resume. But you could also Google David Chappa music. And what you may find are, you'll find my YouTube channel. You also find some spots on the Fox Morning Show in Branson, Missouri, where I'd always stop off before heading to Tennessee to do some recording. So David Chappa music on Facebook, Instagram, and YouTube.
Thanks so much for joining today, David. Always fun to catch up with you, and I'm sure we'll chat again soon.
I hope so. Thank you.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.